Hello and welcome everyone to our FAIRWork webinar, today with the title AI-based optimization for decision support, the FAIRWork approach. And today our colleagues from Human Research, especially Herwerk Zahn and Julia Juden, will present their work and how they tackle the problem with AI-based optimization in the production environment for our FAIRWork project. And without further ado, I hand over to Herweg, who will start the presentation. Thank you very much. You can start.
Thank you, Christian. We will present this AI-based optimization for decision support today and explain you the key ideas behind that. Before I start, I want to explain the FAIRWorks idea. The core idea behind FAIRWorks is to enable democratic AI-based decision support. As you can see in the picture, we make decisions to support individuals, or this can be also groups of people in their daily work. The manufacturing industry, the most important thing is they make products, and this is the main goal. And to do that well, there are many decisions to make for that, and we want to support them in FAIRWorks with our approach. What kind of decision they have to make? For example, they have how to assign the right people to a line, for example, or how can I implement processes faster? Where can I save energy in my process? Where can I save costs, etc. As a rule, in general, you have more than one goals at the same time. So, for example, you want to reduce costs in the process, and to save energy at the same time. So to implement such decision process in the company, you need the adequate IT infrastructure. As you see in the picture below, we want to do AI. So we need for that data. In our project, we get data can be from persons, can be from vehicles, can be from robots, or can be from lines. In our decision process, we want to do something. We show today some examples. This can be one AI service, this can be several AI services. With the orchestrator, you can combine them and make a process model for decision support. And the configurator in this picture is there to deploy this AI solution in the company itself. These are the main ingredients in our project for making decision. Why this is important for the manufacturing industry? First of all, manufacturing industry is characterized to rapid change. This is a very dynamic market, and there's an increased need to customize products. So to do that, you need to be very flexible, and you have to adapt to different situations for the future success. It's a very flexible environment, and the daily business has always looked for ways to improve how they work, spend less money, and make better decisions to make better products. So optimization is more than just to improve efficiency. It's important to implement strategic goals and to make out of it a good advantage for your company. What does now AI-based optimization mean in the production industry, and how we approach this? First of all, what we explain you here a bit, when you do optimization, you need to identify a problem and a way to optimize the process. This is the first key question. And the second is then afterwards you have to select suitable AI methods, maybe combine it, and in this way you enhance your decision making in this context. Our work was carried out as one of the research tracks, which was planned and elaborated in FAIRWorks. And here today we explain you some examples, what we have done here in the last couple of years about that. So as I said before, it's quite important that you have a clear goal. To understand the process of a company, we used design thinking. We prepared some workshops elaborated this or carried out this workshop in the company itself. Then we get a good overview and understood the goals of the process and the improvement potential of the process. And in this workshop, we discussed also with the users, is the data available for that, and how we can come to the data, what kind of work we have to do that in this way. So the end of this workshop, or the result of this workshop, were a good decision process design. This was then used to implement implement our solution, and this could be later on integrated also in our infrastructure. As I said before, the most important thing is to define an optimization goal, define a model, implement it and evaluate it and integrate it, and this stuff then in the models. As a general workflow, we have here in principle a few steps. Also identify the problem with our workshops, then we made a good plan on how we implement it and make a good solution. And this implementation step, here we have 3 sub-steps. First of all, we have to select the right data. Then afterwards we develop models and integrate them in our solution. Then we test it, evaluate it, adjust it, maybe change some part of the configuration, measure the overall success. And this is a continuous cycle which was implemented and improved. And in this way, you can implement good AI-based optimization stuff in the company. As one example, here the decision process for FAIR allocation. This was the first standard example. It's about a line, and you have several people available for this line. Not all people can do everything, so some are limited in carry out heavy weights. Others, there are also availability issues and capability issues. And this is a job then to assign the best person or the best group of persons to the line for a given job. This was one of the examples. Here this worked also out and recently published the beta about the fairness of this allocation. This is one of our examples, what we carried out. Another example which we worked on in the research track was research on optimization of transport. The example is, the point is that you bring resources, this can be persons or products, from one place to another place. When you define and implement some AI-based optimization service, you need to define, as I said before, good optimization objects. This could be, for example, minimize the transport completion time for all the transport what you carried out. Another objective could be maximize the satisfaction of the participants. In this case, this can be the drivers, this can be the operators, or also the managers. So, for example, to fulfill the satisfaction of the drivers is that you have a good brake handling for them. This is important. And then you have in such a model always some type of constraints. For example, when you carry out the transport, you need the right vehicle. Which should be available. You should not have a breakdown for the vehicle, and then you have to consider also other aspects, the location of the vehicles, etc. And if there is a fixed orders or the fixed schedule, or you have on-demand orders. As an input, you get then from the managers some listed orders. And then in this work, we assign then the best transport with the best vehicle to the order, and this can be then carried out. What we need to consider here is also, for example, when we do this type of algorithms in a factory, you need the factory layout is important, and also consider the right driver, the right resource, in this form vehicles, and to assign the best match of products to the right vehicles. This needs to be considered, and the output of these algorithms, this approach, is then the assignment of the drivers to the vehicle. In principle, from a mathematical point of view, these are dynamic dial and write problems. This is a very dynamic stuff. One dispatcher assigned this to the transport. Here you have a reference about the history. It's old stuff. But the challenge for industry or the challenge for some application domain is that sometimes you have very limited time to make the decision, and you have to find good strategies to fulfill the job in this sense, and fulfill also the time constraints which is given by the problem itself. From a worker perspective, workers in this process has to accept an order, pick up the items, carry out the transport, deliver the items, and then confirm that the transport was carried out. This can be by click, or this can be also automatically, depending what type of technology you use. In principle, for the implementation, you have usually in this type of algorithms an initial phase where you have to set up the crew assignment, this type of resources, what is available, set the right transport map. Then, depending on the situation in the factory, or we implemented such algorithms also for hospitals, you have to check if you want to combine an order. That means if one transport goes from A to B or to C, and then he pick up at B, for example, additional items. This is one aspect, and the other aspect is what kind of planning horizon, what you consider. Do you the planning consider the next transport in the next half an hour? What is your planning horizon? Depends on the situation, on the application use case in the company. And then you do an insertion phase in the list of transports which should be assigned. This could be a new transport order, or you can also combine transports, as I said before, by considering spatial and temporal distances in the graph, which is included in the transport map itself. And the last step is always an improvement phase. When you insert, pick up additional transport, or assign additional bar jobs to the order itself, you have this insertion phase, and then you check what is the best possibility. And if this outperforms the existing solution, you take the better solution, and then you iterate several times to find a good solution. We have also done a publication for this work 2 years ago. So this was 2 examples what we have researched in our research track. And now I hand over to Julio. He will talk about calibration documents by using AI. Thank you, Julio, and please go ahead in your presentation.
Thank you, Henrik. Next slide, please. Before we talk about optimizing a workflow, we first need to understand the current workflow and the framework in which it operates. The use case was that we have a client that contracts a manufacturer, and the goal is to produce an electronic device. And since this electronic device needs to adhere to like requirements and standards, you need to certify the device. So what you do is you send the device to a calibration laboratory, and there the device undergoes tests. And based on the test results, the calibration certificate is issued. And afterwards, the issuer sends back the device and the certificate to the manufacturer. The manufacturer needs then to evaluate and check the certificate if it adheres to, or like not the certificate itself, but if the device scored the needed results. And this is a step that could be optimized and would be optimized later on. Because, for example, the manufacturer about 3,000 certificates per year. Each certificate is, or like a certificate can become quite large, and checking all of the various data sources and all of the results, it can take up to 10 minutes per document to check it. Which means that it's super time consuming. There is a risk of human error and a risk of inconsistencies between the evaluation of humans. Next slide, please. So it's a very good idea to automate this process and let the computer do the more tedious tasks. And an optimization could look like that. We're gonna write a script or a software that parses all of the PDFs and extracts all of the needed device data and the data related to the testing procedure. With that data, we would need to detect all of the inconsistencies and the mismatches in the data. Can you go back, please? And we also need to check the test results. And all of that needs to be logged so that a human worker can evaluate then the summary output. Next slide, please. And that's easier said than done, because while the core information is consistent across all different laboratories, the way that they present information isn't. Here you can see two types of certificates from two different issuers. And as you can see on the page, all of those laboratories have their own keywords, their own layouts, and their own way of grouping information on a PDF. And that also spans across like other areas of the certificate. And the whole variety poses a challenge in extracting the information. Please, next slide. But the bigger problem is retrieving the information from the PDF itself, because initially PDFs were not meant to be an input data source, but they were constructed as output-focused formats with a fixed layout, which means that text isn't really stored as a readable paragraph or, for example, words, but as individual characters positioned on the page. And also all of the formatting information are stored with each individual letter. So it's hard to reconstruct the semantic structure of a PDF, especially if the tools that produce the PDFs don't take advantage of the full capacities of the PDF. That leads to documents that are like dumb and that require more intelligence during the processing. Even harder is it to extract information out of tables. The first table you see is a very easy case because the outlines clearly mark where the table is and clearly separate the inputs. However, there are like different kinds of tables, right? And the table below is one without outlines, and that makes the extraction of the text much more difficult, but still doable. Next slide, please. However, the tables could also look more complex, like the next result, or like the next table that you see, where the issuer decided to summarize the result of two rows and center it in between those two rows. So that is very hard for a machine to extract because it doesn't really know which row this centered line belongs to. And occasionally you get something like that, which is more of a table that humans can easily read, but due to the misalignment, the computer has a really hard time extracting the information correctly from this. And no file is the same. And that especially is the case for the results of the tests, because sometimes they're in tables, sometimes they are presented in dictionaries. You have to extract them. Next slide, please. And that's where artificial intelligence comes into play. We quickly realized that a generalized approach does not yield good results. And to increase the reliability of the data extraction, we had to tailor the logic to each format the certificate issuer uses. Therefore, we implemented rule-based AI, and that basically means we implemented a set of rules that the script follows to check the data. That includes, for example, we detect keywords in a dictionary kind of style. We derived layout. We are able to interpret the table structure. And we also implemented rules for the whole validation logic. And since table extraction is really difficult, since the tables can look vastly different, we need to refine this a little. And that's why we also implemented a more intelligent approach to table extraction, where we first decided on common facts, for example, expected column names or characters. And then we iteratively refined rules based on the detected layout patterns, blacklisted or whitelisted terms, and the expected values. And that allows easy adaptation to new calibration issue formats. Next slide, please. And if you compare the new to the old workflow, what we improved is, like previously, each document had to be checked manually. Now all of the documents are pre-filtered, and only the flagged documents need to be manually checked. Previously, you had, like, it took approximately 10 minutes to check one certificate, and now it only takes a few seconds. And also previously, there was a high potential for human error or inconsistencies, and this was eliminated due to a consistent rule enforcement. That allows to reallocate skilled labor to tasks of much higher value. And that's why manual tasks have a high opportunity for optimization. Thank you. You can go to the next slide, Herwig.
Okay, thank you, Julia, for giving us good insights in this type of problems. Now we see, to sum up, as you see, simply put, AI isn't just a tool, it's a key to handle here complex things in factories. This is a good technique to stay competitive and flexible, and factories really need to include that and use this technology in the company itself. And in FAIRWork project, we carried out a few good problems to make better decisions, which is quite a key, leading the factories to more adaptable and work better and make better decision and improve their process. That's to sum up here. And thank you very much. And now we are open for questions.
So thank you very much to the two presenters for the interesting insights in optimization in FAIRWork. Are there any questions from the participants? Anything that must be clarified or should be explained in more detail? Thank you very much, everyone, for joining and for the presenters. And next week, we have our other colleagues from Union Research, for example, Lucas Blätter here, who will introduce more on the side of human factors in FAIRWork. It will be next Friday. We will You will find it soon on our webpage and on our LinkedIn post, so stay posted. And if there's nothing else, then thank you very much. Have a nice day and see you hopefully next week.
Okay, thank
Bye.
you. Bye.
Right. Thanks.
Thank you. Bye.